Verify that the following lines form a rhombus. Okay, let us begin. Let's try to understand the problem graphically first. Now let us suppose that the side AB of this quadrilateral is denoted by the equation square root of 3x plus y equals to 0. Then we have the side BC. Let's say BC is represented by square root of 3y plus x equals to 0. Then we have the side CD. CD is going to be represented by the equation square root of 3x plus y equals to 1. And then we have DA. DA is going to be represented by the equation square root of 3y plus x equals to 1. We need to show that ABCD is a rhombus. So what we'll do here, let's say we take the side AB and BC first, and we will solve this two equation that is going to give us the coordinates of the point B. So let's do that. So solving AB and BC. So this is a standard linear equation in two variable. So the first one will be square root of 3x equals to negative y, or we can simply say that y is going to be equals to negative square root of 3 times x. You can substitute the value of y with negative square root of 3x in the second equation, that is for the equation of line BC. That's going to help us obtain x. So here we have square root of 3y. Now in place of y, we'll replace it with square root of negative times square root of 3 times x added to x equals to 0. So that gives us negative 3x plus x equals to 0. So what we have here is negative 2x equals to 0, or simply put, x comes out to be equals to 0. So we have x equals to 0, and when we substitute back this into the equation, the corresponding y value comes out to be equals to 0 as well. So here we have obtained the coordinates of point B. So that is 0, 0. Similarly, what we can do, we can solve the side BC and CD. That means there's two sides, and that is going to give us the coordinates of point C. So here what we can do, we can use the distance formula. Using the distance formula, we can show that the opposite sides are going to be of equal length. We can show that AB is going to be equals to DC, and that's also going to be equals to BC equals to DAD. So all the sides are going to be equal, but this does not tells us exactly that ABCD is a rhombus, because ABCD could be a square as well, because the sides of a square are also equal. So next what we'll do, we're going to consider the diagonals. So we're going to find out the equation of the diagonals AC and BD. So equation of AC, all we have to do is use the 2-point form of a line. So here we have 2y minus square root of 3 over 2. So here we're considering x1 comma y1 to be equivalent to the coordinates of point A, and x2 comma y2 to be equivalent to the coordinates of point C. So we have y minus square root of 3 over 2 equals to, now we need as y2 minus y1, the difference of the y coordinates. So we'll do y2, which is negative half, and from here subtract the y coordinate of point A, so that's negative square root of 3 over 2, divided by the difference of the x coordinate. So we have square root of 3 over 2 added to 1 half. This is going to get multiplied to x minus x1. So x1 here is negative half, so we get x plus half. So we have y minus square root of 3 over 2, that's going to be equals to negative 1 multiplied to x plus half. So solving this, we're going to get, so here we have x plus y, so that's going to be equals to square root of 3 minus 1 over 2. Similarly, we'll try to find out the equation of BD. The equation of the diagonal BD, that is going to become x equals to y. So now that we have the equation of the two diagonals AC as well as that of BD, so let's do one thing. Let's find out the intersection. So let's say the intersection is at point O. All you have to do is solve the two equations. So we have x plus y equals to square root of 3 minus 1 over 2, and we have x equals to y. So when we solve this, x comma y, which is going to be the coordinate of point O, that becomes equals to square root of 3 minus 1 over 4, and the y coordinates is going to be square root of 3 minus 1 over 4. Now that is only telling us that AC, the diagonals, this is telling us that the diagonals AC and BD bisects each other at the point O. So here we started out by considering the quadrilateral ABCD. We were able to show that the sides are of equal lengths. That means AB, BC, CD and DE were of equal length, and also the diagonals bisects each other. So that means it is true that ABCD is indeed a rhombus, hence proved.